Okay, so thank you very much, Professor Govindarajan. I'm happy to be here uh, on what is simultaneously interesting occasion, both a talk. Can you hear me up there, balcony? Okay. I have a reason for staying like this. So, uh, it's doubly matter of some pleasure because on the one hand, I have been associated with this institute. I have also been associated, as Govindarajan pointed out, with the Tamil Nadu Science Forum. So in both cases, I think sort of is much better than giving two talks. You give one talk which combines both situations. Anyway, would like to speak today about the IPCC's special report on the 1.5 degree goal. To give it its full name, this is the Special Report on Global Warming at 1.5 degrees centigrade. The IPCC, stands for the Intergovernmental Panel on Climate Change, and this report is still out there. It's a very unique report. It has a unique history. And in the history of dealing with this global problem, which is the problem of global warming, the report is likely to play a important, well, if not important, certainly significant role. So I think for these reasons, one should take this seriously. And this has serious implications for our country's economic, social, and political future. It has quite a bit to do with our future choices for development. So, taken all together, I think this is a subject worth discussing. So, before I get into the details of the report, I think I'll find it useful to talk to you a little bit about the basics of global warming. Now, this is one of those interesting things in our country where everybody is knowledgeable, but not quite knowing precisely what the phenomenon is about. I'm sure in this audience such numbers are not very large, but nevertheless I would like to run you through some of the basics just so that we have the coordinates straightened out, so that we all know, we are clear about what we are talking, and there is less room for misconception. So we are talking about the changes in the climatic system. This leads to, primarily in the first instance, it leads to the rise in global temperatures, primarily meaning the atmospheric temperature or the global mean surface temperature, inclusive of both temperature over land and sea. This, however, the choice of the name, okay, is somewhat problematic. And in fact, in this business, there is a constant interaction of science and policy, or politics if you wish, which you must always keep in mind. So climate change seems like a friendly, neutral term, no? Climate change. So things change. So it may be changes for the good, it may be changes for the better, or it may be changes for the worse. So in this case, actually, we are talking about a situation which many people think constitutes a threat to the very existence of humanity on this planet. So if you ask someone like Professor Noam Chomsky, he thinks that the world before it has two major global challenges. One is the presence of nuclear weapons, which can wipe out the planet even today in very short order. And the other is perhaps something which will evolve more slowly, but perhaps could be equally destructive, namely the problem of global warming. So the term climate change was the product of much negotiation at the first global climate conference in 1992, which saw the signature of the United Nations Framework Convention on Climate Change. So at that time the argument was we were not sure what was the origin of this change, whether it was all warming and so on and so forth. There were many doubters around. There are still a few, but there were many more at that time. So what was actually a phenomenon which should be called global warming of anthropogenic origin got instead renamed as climate change. So it is global warming of anthropogenic origin, namely the heating up of the earth, primarily the surface temperatures, which is due to primarily at least due to human activity. So how does this occur? This occurs because of the greenhouse effect. The greenhouse effect takes place in the case of global warming because of the presence of primarily carbon dioxide. It is way and away the most important greenhouse gas, but there are other gases which can contribute to global warming, and they also contribute to a greenhouse effect. So let me remind you just very, very briefly that the greenhouse effect is perhaps the simplest at this stage. I don't want to get into the technical details. By analogy with the heating of the inside of a car left in the sun with all its windows rolled up. If you think about that, you get the same basic idea. In that case, the light from the sun and primarily the solar radiation, which is a lot of it is in the visible and ultraviolet or other spectra. It enters through the glass. It strikes the material inside the vehicle, which leads to its warming up, namely the energy. A good part of it is re-radiated as heat waves, and glass, of course, is not transparent to the passage of infrared radiation. So the infrared radiation is substantially trapped, and as a result the inside of a vehicle gets extremely hot if you leave it out in the sun in the open. So the phenomenon of greenhouse gases is very similar. The role of the glass is played by the greenhouse gases. What heats up is not the interior of a vehicle but the earth as a whole. But with this simple phenomenon, whose essence of the phenomenon is fairly straightforward and simple, the result is a far-reaching chain of causal effects and feedbacks which afflict the entire earth. The entire earth understood as a physical and chemical system, as a geological system and as a biological system. In all these dimensions, the life on earth, all the various cycles, the functioning of all these subsystems that make up the entire earth are affected by this. So we better, as a consequence, take this rather seriously. And of course, if it affects the geological, the biological systems on earth, it is obvious that it will have a rather serious effect on human existence and human society. So this is pretty straightforward. Much of it is known. I just want to alert you to the fact that the greenhouse gases and global warming have nothing to do with the ozone layer. That's a separate problem. So please don't confuse ozone layer and global warming. Let me at the outset also tell you that earthquakes and tsunamis have also nothing to do with global warming. Okay, let us be absolutely clear. Unfortunately, now people think that every disaster occurs because of global warming. They do not. So there are many problems which are not necessarily global warming. So the main culprit in global warming, as I told you, is carbon dioxide. And to next most important in the scale is methane. Nitrous oxide is a non-carbon gas, but it arises primarily when the excess nitrogen from urea fertilizer in general mixes with water sources. Nitrous oxide is a potent gas. This does not mean that we immediately hold our farmers responsible for climate change. That unfortunate section of our population has a lot more problems to worry about immediately than global warming. So don't let us not get diverted on that, hopefully. Anyway, so there are a number of other gases, and eventually the question is, what are all the effects which may heat up the earth or which will cool the earth? So you have to worry about, say, aerosols, fine particles in the atmosphere. Sulfur dioxide, sulfur aerosols cool the earth. So volcanic eruptions are, it's a strange way to put it, but from the point of view of global warming, volcanic eruptions are good, if you wish. Not very good for the people living around the volcano, but for the globe as a whole, it can be good. And when really big volcanic eruptions take place, in fact, in the global record of CO2 concentration, you can see their impact. On the other hand, there are other aerosols which can contribute positively. So there is some debate which is still ongoing about the exact extent of, say, the effect of black carbon, as it is called, the carbon that comes from soot and incomplete combustion, etc. Many scare stories have been created about it. These have been debunked, but the exact effect still needs to be understood more in detail. There are other kinds of activity which may or may not contribute to global warming. So, for instance, a large-scale change of land use leads to global warming, not because that directly affects the temperature, but because the absorption of carbon dioxide by vegetation is disturbed in some form. So if there is stored carbon in vegetation and you release it, or that continued storage you block because you cut trees down and so on and so forth, that also contributes to global warming. So in the end, we take all the various effects, and you can see in the IPCC reports or on the net in various places a nice little tables which show you the balance. I am not going to show much of those kind of pretty pictures. I sometimes think that they distract from the actual issues that we need to be discussing. So this is not a climate talk with nice pictures. No polar bears, I assure you. Okay. So the question is, how much greenhouse gases can you emit? Now you might ask, carbon dioxide is a pollutant, and if you think of carbon dioxide as leading to global warming, why should you ask how much carbon dioxide can you emit? Fortunately or unfortunately, we also need carbon dioxide for life on Earth. Carbon dioxide is not original sin. The atmosphere of Mars has no carbon dioxide. As a result, it does not retain any of the heat that falls on it and is re-radiated. All of it escapes to outer space again. Okay. On the other hand, the temperature of Venus is much higher than you would suspect from its proximity, relative proximity to the Sun, and that is because there is really a very active greenhouse effect on Venus, and that is one of the places where the greenhouse effect was first properly understood in the context of the Venetian atmosphere by Carl Sagan, among others. So we do need carbon dioxide. So the amount of carbon dioxide is also extremely small. We are talking about the range of between at 350 parts per million. Carbon dioxide is a healthy presence in the atmosphere. It does all kinds of good things for the flourishing of life on Earth. You go past 400, you seem to be in trouble, and if you are reaching 450, we really ought to be getting worried. So there's a very narrow range of variation, and in the history of the Earth, this narrow range has been breached on many occasions, and there's a long story of naturally occurring climate change. Okay. So we have even, I think, reached 600 ppm at some point, at which point, you know, the Earth is much warmer, there are very few ice caps and so on, water is more present on Earth, the seas are much larger in extent. So the Earth has a complicated history of global, the variation in its temperature. But that's not what we are talking about here today. We are talking about purely the effect that humans cause. Many people think that because we are talking about the globe, the whole Earth, how can puny human beings affect the global system? Answer is, whether you like it or not, the answer is yes, you can. And that's the lesson that we have learned from the climate science of the last 30 to 40 years. So we have to understand what is the limits to how much carbon we can put in the atmosphere. Now, one of the most interesting outcomes of the fifth assessment report of the IPCC in 2014, I will talk about the IPCC a little more as we little later in the talk. But one of the important things from the report was the idea of a global carbon budget. This was a very important shift in our understanding. Earlier, the general way of thinking about the problem of how much you can emit and how much warming would result was to think of what people called an emissions trajectory. So it's like a curve where you plot how much carbon emissions take place every year. So you get a curve, if you wish, and you then say when should the curve peak, and you know how should it fall. These were all thought to be very relevant to the question of the temperature increase. As it turned out, and AR5 made this very important contribution based on the papers which had been published earlier, this is not the way to think about it. So what it turned out was that the amount to which the temperature rises is roughly speaking linearly proportional, is linearly related to the cumulative emissions. Cumulative means at the end of that period the amount of emissions must go to zero. So if you have emissions starting at one point in time, emissions ending at another point in time, The total emissions in this period is what governs the temperature increase. Now, this is a very important shift in our understanding, because this gives a very clear and precise idea of how to match human activity to what will happen in terms of warming. Now, you have to be a little more careful. The fact of this is not about how much carbon dioxide remains in the atmosphere. There is a whole carbon cycle. Atmosphere, the oceans absorb carbon dioxide, they also release carbon dioxide, so the small net flux into the ocean. Then between the upper ocean, the middle ocean and the deep ocean, the carbon dioxide circulates, and in fact the largest amount of carbon dioxide on Earth is found where? At the bottom of the ocean. This is the biggest repository of carbon, even more than the carbon which we presume exists in the mantle of the Earth. So one has to think this through. At the same time that the carbon cycle involves vegetation and so on and so forth, but the proportionality I was talking about does not worry about these details. So it is something that comes by the study and the use of climate models. So however much we emit over a certain period, starting at zero emissions, ending at zero emissions, this total emissions determines up to probability and uncertainties. It determines how much the temperature will rise. So the question about a target for limiting global warming then reduces to a rather simple question: how much CO2 can we globally emit, provided we want to stay within 1.1 degrees centigrade, 1.5 degrees centigrade or 2 degrees centigrade. Okay? So let me say a couple of words about these these numbers: 1 degree centigrade, 1.5, 2. So when I say a temperature limit of 1 degree or 1.5 or 2, I am referring to the increase in global temperature from when we started emitting carbon dioxide in a substantial way, which was at the beginning of the Industrial Revolution. So roughly speaking, if you want, you can take 1850. Nowadays, by agreement, people have shifted it to 1870. So that would be the starting point. So the rise in global average temperature from 1870 to the present or whatever time period. However, please be careful to note that when you say 1.5, please remember that the difference in temperature, even in a place like Chennai, between summer and winter, is of the order of 7, 8, 10 degrees. There are other parts of the world, the variation is much larger. So a place like Delhi, for instance, there's 25 degrees. So the temperature in the Arctic is not the same as the temperature in Kanyakumari. So what exactly are we talking about here? So when you say global average temperature, global temperatures, you are talking about the annual average temperature taken as a weighted average over the entire surface of the Earth. So you have to worry about this. You don't have enough weather stations all over the middle of the Pacific Ocean. You don't have weather stations all over Antarctica. But you have a lot more weather stations in United States, but you do not have so many in, say, I don't know, Rajasthan or something like that. So there is a lot of effort which is required to reconstruct this quantity that we call a global temperature. So I really think that you should not take seriously people who think that if you open the window and look out, or you just wander around the road and ask somebody, oh, do you think this summer is hotter? That is not a very useful way to establish whether global warming is taking place. So many people think that this is a very democratic, pro-people thing to do. We must go and ask the farmers. They have knowledge of climate change, what happened. Unfortunately, farmer can't tell you. Okay, so he may think it is hotter because his crop is not growing well. His crop may not be growing well for all kinds of other reasons, and even in the national sample survey of the government, there's a big debate about whether you can ask, people to recall what they ate. Forget temperature, what they ate over a period of 30 days or 1 year or what. So asking people's impression of temperature over a period of 1 year or even 20, 30 years, okay, and therefore trying to determine whether global warming has taken place is frankly, in my opinion, if you ask me, absurd. Okay. Unfortunately, because it is an environmental issue, this is considered very democratic and popular, but it is thoroughly unscientific and we don't help anyone doing this. College students particularly, please note. Okay, because everybody wants to do a project, and one part of the project is usually going and asking farmers whether, climate change is taking place. People don't know. Okay. So, with these little sort of caveats in mind, so the question is, what is the limit? So, the Paris Agreement clearly has that the limit, we will definitely, the target is staying below 2 degrees, but we will make every effort to stay, not to cross 1.5. Okay. So what is the carbon budget? I'm not going to put the exact numbers here, but these graphs are to scale. So you see the budget for 2 degrees and the budget for 1.5. There's not that much of a difference between the two. So until 1992, okay, this is the amount that has been already emitted. There is a lot of technical details here, and I am not saying this is carbon dioxide, there are non-carbon dioxide gases, their contribution to warming is a little more complicated, there is a lot of technical detail, but that does not, I think, take away from this very basic story of 1.5, 2 degrees and this. So this is what has been emitted so far. And by 2017, this is what has been emitted. So basically, there is very little that is left. The white portion is what is remaining of the carbon budget for 1.5 or 2 degrees. So you see, there is, in some sense, though the bulk of the carbon budget has already been taken up, which is that red part of the bar in the 2 degrees chart, but there is something left. In the case of 1.5, there is very little that is left. So when the Paris Agreement was signed, one climate scientist in fact suggested that 1.5 was in the rear view mirror, meaning it had already, the target was gone. Anyway, at the current rate at which countries have promised to cut emissions, you remember that in the Paris Agreement, all the countries which have signed it, okay, have or ratified it, have submitted what is called a nationally determined contribution. NDCs they are called. So NDCs are your country's voluntary commitment to how much they will reduce their emissions. There may be direct reduction or it may be an implicit reduction, like in the case of India and many other developing countries. Now, the object of this graph, if you take the NDCs, which typically run up to 2035, by 2030, the budget is gone for 1.5. So we are not talking only about current rate of emissions. Even the promised reduction in emissions, if you take that into account, we will get up by 2030, the 1.5 budget is gone. And of the 2-degree budget, a very little is left. Who was responsible for this? Now, the problem is that, okay, right, we have to reduce emission. Who is going to do how much? This is the problem. If that were not the problem, we would solve the problem overnight. Okay? But the problem is who will do how much? And who will do how much is very important. And it is not enough to be a morally good person and say, I am very good, I care about the earth, so my carbon footprint is going to be zero. However you define a carbon footprint, jo bhi ho, you say carbon footprint is zero. But that is not very useful, because if everybody else is emitting, okay, your sacrifice is what? Not useful. I don't want to say useless. It may inspire people, but it is not exactly useful if other people are emitting. So in economics, this is what is called a collective action problem on the commons. So if you take it, okay, if I take it, okay, or you take it and I renounce my share, that doesn't stop you from taking it, then we still have a problem. So, of course, so from my point of view and the point of view of several others who have studied the question, 1.5 C is impossible and 2 already is very difficult. If you take the NDCs which have been promised, they will take us to 2.8 or 3.2. That too with some extrapolation, etc. So now the question is, who is responsible? And here is a quick run through about who is responsible. Of the total up to 2017, 41% comes from USA and European Union, even though they constitute 11% of the population. Now, sometimes there is a big debate. Why are you using this per capita principle, this, that? But if you have a ration public distribution system and you say a family of 2 and a family of 8 will get the same amount of rations, none of us will think that that is particularly fair. Okay? The same thing should apply to any resource. And I have already told you, carbon is not only just simply a global warming pollutant. Carbon is also a necessity, because all the development that we have had so far depends on carbon. We have to move away from carbon, but it is not obvious that we have the means to do it on the scale of the next 15-20 years alone. So anyway, the past 41% up to 2017 of a part of the population, which is 11% of the globe. Other rich countries contributed 17%, as with Japan and so on and so forth. They contributed 6%. The bad boy, China, everybody says China is the biggest emitter. They have contributed 15% of the total emissions. They have 19% of the population. The rest of the world, 27% of the emissions, even though they constitute 64% of the population. So there is really no need for Indians to feel over guilty about global warming. Okay? So everybody now says, oh, we must do something about global warming. There are many other things, education system, health, our urbanization, Swachh Bharat, it is not becoming Swachh Bharat, solid waste management, learning to handle garbage, cows on the streets. There are a lot of things to worry about in our country. We are not even the world's biggest polluter. Okay? So partly because we do very little industry and manufacturing for the size of our economy, we are so poor at manufacturing, we are not even good polluters. Okay, that's the other side of the story. We have a society which cannot produce. So this is the story. So this is what is left of the future on top of a highly unequal distribution. So now you may ask, so you, T. Jayaraman, are sitting here and saying all this. Huh? What about all the fellows you are in IPCC? Huh? You think you are smarter than them? Why did they go and do this? The result is actually that this is the product of a process. Let me very quick, how much more time do I have? 15 minutes? Okay, that will manage. So the IPCC, as I told you, and I must emphasize this, is the Intergovernmental Panel on Climate Change. It's very important, remember the word intergovernmental. It was set up under the aegis of the WMO, the World Meteorological Organization, and the United Nations Environmental Program in 1988 or 89. They have an excellent website which you can go and read up all the history. I'm not going to go into all the details, but the intergovernmental panel part of it is quite serious, and you have to see the significance of that. One thing is that the head of the leadership, the executive body of the IPCC called the Bureau, is elected by the governments in a plenary session. There are 192 countries, they all sit together, there is a whole election process, they spend 2-3 days over it, and this takes place. So they elect the chair of the IPCC, the vice chair. Each working group has 2 co-chairs. There are 3 working groups. Working group 1 deals with climate science, working group 2 deals with the impacts of climate change, working group 3 deals with how to reduce emissions, the policies, energy production and things like that. So each group has 2 co-chairs, typically one from a developed, one from a developing country, and then there are vice chair for the working group, etc. All of it, once they are elected, the governments also nominate authors for various reports, etc. But the final selection of authors is done by the Bureau of the IPCC. Okay. Whenever a report is written, whether a special report or the every 5-year assessment report, the first draft is reviewed by experts, the second draft by experts and governments, and by that time the report gets rather big. So they produce a summary called the Summary for Policy Makers, which are the main lessons from the review of literature that the IPCC conducts to make its report. And this summary, okay, becomes the most important part of the negotiations, because these have to be agreed on by all the countries. So the IPCC does not do original research. So many in the media, they say, oh, the IPCC, the world's body of climate scientists, says. What the IPCC says is what the review of the literature that they have conducted, what it says. So you have to be clear about that distinction. So finally, there are repeated reviews, and there is a last big meeting where all the countries come with their delegations of 2, 3, 4, 5 people each, and they sit there and they agree on this summary, which is the most important part, in a line by line, comma by comma, full stop by full stop negotiations. So I can tell you that that is what what happens, because in the last one on SR 1.5, I also happen to be present. Okay. So now there is something about this cut paste from PDF that gives me trouble. And you see these little squares over the text. Unfortunate. Anyway, so the 1.5 degree warming special report is peculiar because this was not something, one, that the IPCC decided to do by itself. It was a decision of the Paris Climate Conference to invite the IPCC to present such a report. The second thing is, already the Paris Agreement made it clear that 1.5, it says, and pursuing efforts to limit the temperature increase to 1.5 above pre-industrial levels. So in some sense, they had already decided politically that 1.5 was good. So it became a little bit of an effort to make it happen. Okay. That, of course, is always a problematic issue in science. All scientists are familiar. When you want a result, then you are in little bit of a trouble. So poor Kepler, for instance, a few hundred years ago, decided he wanted perfect circles, perfect spheres. So he tried very hard to fit the observational data to perfect spheres. Didn't work. And he was an honest scientist, so he didn't cook the data and produce spheres when there were none. So he recalculated, and that's why you got elliptical orbits were sort of found. So it's always very problematic when you desire a result in science. Okay. Unfortunately, here somehow 1.5 seems good. See, environmental science is not like other sciences. So, a colleague was talking, Shiva was talking about femtosecond laser or, beta oscillators, etc. If it works, okay, he'll do something else. He's not saying, oh my God, the future of humanity is at stake, the femtosecond oscillator, is not happening. Or the femtosecond laser is not happening. It doesn't matter. Whereas, in the case of global warming, 1.5 or 2, you are not neutral about it. You see, it becomes a question of 1.5 or 2, is it good or bad? So you somehow want to pressure yourself or find every possible way to argue that 1.5 is possible. Because of course, 2 is obviously more problematic than 1.5. Less warming, better it is. No question about it. But then, should you want to make it happen? So you try very hard to make all kinds of arguments. So people like me who say, what 1.5? They say, So, and there are among countries, the small island states, many of these who have problems, who are threatened by sea level rise, they have the view that the lower the temperature, the better. So when we talk of India's need for development, they say that it's your development, it's my existence. So you see, the problem of doing environmental science is tricky. We have an excellent example. in the Western Ghats report, there are two reports. One headed by Professor Madhav Gadgil. The other was headed by Dr. Kasturi Rangan and had people like Sunita Narayan, etc., the well-known environmentalists on it. So they produced two different reports. And they didn't, in fact, in the beginning, Madhav Gadgil wrote this very angry letter which was published recently. He wrote to Kasturi Rangan, your report is awful, why did you write such a report? So, but if Shiva writes, has a problem with his laser, somebody else is not going to write it. Why did you say that about femtosecond lasers or something? It's not going to happen. But environment is different, and therefore there is a real issue. And to make matters worse, is not even a linear problem. It's a complex, multi-dimensional problem. Parts of the problem involve human behavior, etc. They involve economics, sociology, anthropology, culture. These are not quantifiable. So, do people want to drive cars or not? How do you reduce car emissions, automobile emissions? One thing is, of course, build better automobiles. But then there is also the question, when you build more efficient automobiles, something happens called the Jevons paradox. What people do is they drive more. So, because per kilometer you pay less for petrol, people start driving even more. So, the net result is consumption of petrol will actually increase by roughly 15 to 20% in the United States every time a more efficient engine is released. This was noticed by Jevons in 19th century England, where he saw that the more, even though England, the industry was getting more fuel efficient, they were actually burning more coal. Okay, so these kind of things start happening. So you see, environmental science or climate science is not the same way. Even the behavior of the scientists who practice it is somewhat different from simply doing, I know, algebraic geometry, for instance, So you are not so this is the background. So clearly the conclusions of the 1.5 report, many of you would have seen it in the media. So let me give you two or three quick highlights. Just summarize the results and point out why we need to inquire into them further. Okay. So, one they say, of course, is climate-related risks for natural and human systems are higher for global warming of 1.5 than at present, but lower than at 2. Our current warming is anywhere between 0.8 and 1, depending on how you measure it. You may make it 0.7 and 9 by a slightly different indicator. So, so roughly in that ballpark. So, they say these risks depend on the magnitude and rate of warming, geographic location, levels of development and vulnerability, and on the choices and implementation of adaptation and mitigation. So what do we make out of this? It's a bit, there's a high level of ambiguity here. But the next is more clear. They say climate models project robust differences in regional climate characteristics between present day and global warming of 1.5 and between 1.5 and 2. Now you see, you have to be careful here. What is robust? Now the first thing that we would say is robust must mean statistically significant. Insofar as it is quantifiable, you must say that it is, you must point out whether it is statistically significant. Unfortunately, the problem does not end there. When it is about temperature or precipitation, there are climate models, and you know how climate models work. They are built out of physics and chemistry laws, so on and so forth. You can quantify. Unfortunately, there is another kind of quantification which is also relevant to this story, which comes from economics. So you can ask me a question if you want about this year's Nobel Prize in Economics at question time. Okay. So let me plant my own question and go on from here. See, if you call the physics department or you call the chemistry department and ask what is the rate of formation of carbonic acid when CO2 dissolves in water at a given temperature and pressure and a certain background concentration of CO2 in the atmosphere. Provided they know that kind of chemistry, more or less you will get similar results, some variation, some new paper, some new result, etc., broadly similar. You call up the economics department and you ask them why there is so much poverty in India. 70 years after independence, you get wildly different answers. There are probably more answers than there are professors in the economics department. But on the other hand, given the tradition of this whole climate change game, a lot of the economics aspect of this report is also made in terms of quantification. And one must always remember when you quantify economics about Amartya Sen's wonderful statement where he said it is better perhaps to be approximately right rather than being precisely wrong. Okay? So one has to be careful. So this robust difference is a problem. Now, in terms of temperature, robust differences, I am quite willing to believe are there. But in the case of precipitation, this is very problematic. Why is it problematic? For instance, if you take the case of India, we do not have a good monsoon climate model. Of the 25 or 28, whatever it is, global climate models, the total annual rainfall is more or less predicted correctly for the past for only about 3 out of this 28. Does it matter? Many climate scientists sometimes think it doesn't matter. Whereas for India, this is the whole story. This is the crux of the story. So why do we put our faith in a climate model that cannot get the monsoon correct? And this is partly because for those who are interested in that kind of thing, these global climate model simulations are solved by sort of, pixel wise, you sort of cover the globe with little rectangles, okay, and you sort of solve the equations in each of these little boxes, 2D or 3D, depending how you do it. So this is very good for pure convective activity, but when there is long distance transport and wind, etc. is involved, precipitation is very problematic to control. So there are issues here which are problematic. Similarly, mean sea level rise on a number of issues, and the final thing which perhaps there were two issues. One is the way the global carbon budget was handled, which, if you remember, in the manner in which I presented, I made evident why it is important. It is also the government of India's position officially that we are concerned about having adequate carbon space for our development. And so this is a matter of interest, and it is very sort of handled in a problematic way in the report. On top of that, so you saw that the 2030, by 2030 with the current NDCs, the budget has virtually gone. Well, I was showing it to you in that earlier set of slides. But now people are saying, one of the assumptions people make is, suppose there is a method of capturing carbon from the atmosphere in large quantities. How large? In the second para you see 100 to 1000 gigatons of carbon dioxide. Are there such technologies of that scale? Answer is no. Is there room for optimism on this? I don't think there is, because there are a number of negative reports which have also appeared on the future of such technologies. So here are other examples. Let me work through one example and then I'll kind of wind up. I'm reaching the end of my time. So there is a statement in the summary for policy makers which says 10 million less people would be affected by sea level rise at 1.5 degrees compared to 2 degrees centigrade, corresponding to the fact that there would be, on some average sense, 0.1 meter lower sea level rise. But the question is, you say 10 million less. 10 million less compared to what? 2000 million, 200 million, 20 million. So you need a scale to understand that 10 million. So if you look, so unfortunately, there was no clarification, and this statement actually made it through the negotiations. But if you look at that chapter, it actually gives the numbers. The population affected with a 2010 distribution at 1.5 would be 31 to 69 million worldwide, and the population affected at 2 would be 32 to 79. Now, if you just take the crude average from both these ranges, then the number difference is not 10 million, but 5 million. And in fact, if you look at the paper, which I am referring to here, there's a particular paper here, the difference is 5 million. And in fact, if you look at extreme sea level events, just like you have a heat wave, you can have a storm surge on top of sea level rise. So that is like an extreme sea level event. There are no substantial difference between 1.5 and 2, and the largest number of people affected are not in developing countries, not in island states, but actually on the eastern coast of the United States. Okay? So this is the story. So the good question is now, is this statement justified? Many of us think it is not. Similarly, on the global carbon budget, throughout the drafting, they spoke only of what was remaining. Meaning that little white stuff I showed you in the bar chart, that's all they wanted to speak about. They did not want to speak about the total budget. They did not want to speak about the who consumed how much earlier. And in fact, there was a very interesting breakout discussion where they said, we as scientists say total budget is different. So I said, I am also a scientist, not only a government representative. So please tell me how you calculate a remainder without knowing the total and what you are subtracting. So finally they went around and the next day they came back, and finally in the SPM, you will find a footnote which says that the total carbon budget is an important concept, full stop. But in this report, the total carbon budget and the amount consumed have not been calculated. So it's very hard, I think, not to see that the scientific conclusions are being of how we perceive each other in the world. If someone says, it's a bit like this. If someone says, I feel bad, I feel nervous, and I'm not feeling good, you take his or her temperature, huh? You put you're a doctor, you put your stent, etc. Say, you're perfectly okay, you are imagining it. Doesn't help. The person feels threatened, they feel ill. So I think there is a story of perceptions here and a story of cooperation of all inhabiting the planet that we must take seriously. So we cannot reject the report. However, we need to not plan for 1.5. Let us be very clear. I think, if you want, there are two things. Can you make the effort to keep temperatures below 1.5 in terms of emissions reduction? And what efforts should you take to what temperature target you should adapt? So, in terms of adaptation, if you adapt to 2, you can adapt to 1.5. You adapt to 1.5, you can't later adapt to 2. It's much harder. So, I think we should target for adaptation, we should forget about 1.5. In practice, we should aim at 2. About negotiations on mitigation, as I pointed out, it is a global collective problem. So, if we are to do anything more than what we are said so far, one has to see demonstrable leadership by the developed countries in taking action. Okay, otherwise I think we are incurring risks in terms of development, and the factual basis, the scientific basis that this report provides is inadequate to claim that 1.5 is viable. In terms of economic feasibility, there is no clear story, as you can read in the SPM if you read it yourself. I want to end by pointing out there is a very basic problem here which all of us as those interested in science should think about. One is the fact that a developed country means that they have a much higher quality and quantity of science and scientific research that they do. There's no doubt about it. That's why they are developed here. Otherwise, we would be developed, by definition almost. As a result, however, since the IPCC consists of a review, IPCC report reflects largely a literature which comes from there. And this literature is written with perspectives which are there. For instance, there is a whole line of papers which believe that farmer suicides, conflicts, inter-country conflicts, intra-country conflicts like Somalia, Eritrea, all of that, it all depends on temperature. So a lady from Canada actually calculated that if you have a 0.1 or degree centigrade rise in average temperature in India, you would have some 100 or 150 or whatever, she had a number, more farmer suicides. It appeared in the original draft of the report, we threw it out. As far as we know, it didn't reappear. But in fact, my colleagues and I we have a published paper, a comment in PNAS. PNAS was where this appeared, the Proceedings of the National Academy of Sciences of the US. They have now a special focus on sustainability, and that is where this paper was published. luckily our comment was also published. We had a few sort of remarks which they wanted edited out, etc. You know how it is. But so that's one part of the problem. So our perspectives differ. And environmental science is not simply about birds and bees and ecology and lightning or rainfall, etc. It's about us. If there were no people in the story, you will have physics, chemistry, biology, or geology. It is environment only when we are in the middle of it. So if a branch falls from a tree, that's the normal process of aging, decay. That is how trees die, branches fall, and they collapse. Nobody weeps over it. But if you are under the branch that falls, that is a disaster. That is an accident. So this is a distinction, I think, which we should be careful about. The second problem is, of course, is an old problem. First world authors are not aware of third world publication. And in this kind of thing, even more so. A third problem, and this is really partly something we should address, despite the importance of the problem of global warming to our societies, to our countries across the third world, our perspectives and our vision of the future is not translated into sufficient scientific work. So that, of course, is, I think, a serious problem. So I hope of the number of people in the audience who are substantially younger than me, I hope you will also consider these issues as serious issues worthy of research in the future. And here I would say there is a very special interdisciplinary challenge that you will not meet in almost any other branch of science. With these words, let me stop. Thank you.